Okay, let me start our lecture for today. Yeah, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we will continue our class. So for today we still discussing. We are still discussing regarding the functional programming by using Haskell. Sorry. Let me share the slide. Okay. Last time we have discussed regarding the introduction to Haskell, and now we are trying to learn about the list, how to implement lists, and then later on, maybe we will continue by how to implement recursive in Haskell. Haskell. Okay. So before we start to discussing regard on the list, now we will try to explore what is the characters, what is the data type, data type that can be used in Haskell. So in several programming language, numbers are also used to represent characters. Haskell has a special type called char for representing character data. So a char value contains one unique characters. These values can be obtained into methods. Firstly, we can write the character itself between single quotes. Gimana? Okay, I will continue. And then secondly, we can write the code point, that is the numeric value which represents the characters as defined in the Unicode standard. So in decimal, we can use between the quotes and a backslash and quote, or in hexadecimal, we have to put an X character between the double quotes. So for the example, if we want to type a character, so if we use code, so we can use 97 in decimal, or if we want to write it in hexadecimal, then we can write as x61. So this one is not 61, but a code in hexadecimal. So this is a series of code 6 and 1. So we can read it as 6 1. It's different with this one. Yeah. This one is a decimal number, so we can read it as 97, yeah, not 97. Yeah. And then using Haskell interactive window or JHCI, so we can check the actual type of each expression that we put to the system. So we can use the colon and T command followed by the expression, followed by the variable name, variable name that we want to observe. So for the example, if we want to print, we want to print or to display a character, then we can write double quotes, and then we put a character between this double quote A, and then if we want to print a character but we use a decimal number, then we can write as shown in the slide. So we use backslash and then 97, and then the output will automatically shows a character. And then if you want to display B character, then we can use the next value. After 97 is 98. Yeah. So we can write it for the instruction is double quotes and then backslash and then 98. Yeah. And also for 99. Yeah. So we can display C character. Okay, next character C, and then we can type backslash 99 between the double quotes, and then we can get the C character. So if we want to know what is the type of each character, then we can give an instruction colon and then T, and then we put this character, A character. Then we can get the A character and then the type of this character that have been displayed. And also, if you want to know what is the type of this expression, double quotes and then backslash 99, then we can use this instruction colon and then T and then double quotes, and inside double quotes is backslash and 99. So the answer of the GSCI is character. Okay, let's demonstrate. So let's demonstrate how to get this result. So we can activate Glasgow Haskell command line interface. Okay, then for the sample, if you want to type a character, then we can get this one, Z, for example, or X, we get this one. And then if you want to know what is the type of this expression, then you can type a colon and then type the character F. Then we will get this result. Yeah. So F is a character. So if you want to check another type such as number, so we will have a different response compared with the previous instruction. Yeah. So here we will get the description. Yeah, the expression is a number, yeah, not a character. Okay. Okay. Next, if you want to call character uh, related functions, means the Haskell provides kind of module, yeah, and then inside of this module contains a lot of function. Yeah. So Haskell provides a function for handling charge type. So we can use this function directly. Yeah, so we can handle or we can manage any kind of variable which has type, yeah, as character. Yeah. So only a few functions are loaded by default. Means when the Haskell or when JHCI initially loaded, then there are around 514 functions initially loaded. Therefore, if we want to use another function, then we have to load another module, not only the default module. So therefore, we need to import a module with a lot more function. So this module or this function are not included in default loading. Means when we starting JSCI environment, then this function will be loaded, but this function only the default default setting. So we have to load or we have to import another module. So here we will import module of data chart library, and after that the data chart modules has been imported. Then we will find more function available in GSCI. Okay. Uh, Now we will continue. Yeah. So we can see the function that have been loaded is larger compared with the default setting. Previously only 500 514, and then right now the function that are available in the module is 639. Yeah. So in Haskell, yeah, everything has its own type. Yeah. So we can find out the type of this function, and then we can use this instruction, yeah, colon and t, and followed by the function name. Yeah. So we can use the same instruction, yeah, to check the function. Yeah. Previously, we can use this instruction. Yeah, this is the second to check an expression. But right now, so we can use this instruction, yeah, to check the function. Yeah. So uh, for the example, to upper. Yeah. To upper is a function that can convert the character or string become capital letters. Yeah. So all of the letters that processed by this function, the letters will be capitalized. So the regular character or the small character will be capitalized, and then later on we will have all letters in as capital letters. So this is the example, how to check the number of function. Yeah. So here the number of function is 514, because we still use the default loading. Yeah. And then after we import this module, then we will have a larger number of the function. Yeah. As we can see, the difference is around 100 120, yeah, around 120 maybe, yeah, 120. So there's a lot of additional functions, yeah, after we import this module. Yeah. And then this is the function, yeah, that have been loaded or have been imported. Yeah. So from this command line interface, we can directly call the function that have been loaded by using this import instruction. Okay, let me try in our command line interface, or maybe it's better I close first and then we will restart, so we can see the initial stage or initial condition. So we are already in the command line interface. Then how to check the function, yeah, that have been initially loaded. Yeah. So we can press tab button, then it will display 541. Sorry, 514. Yeah, 514. And then if we want to know what is the functions or is the function names, you can type y, then the environment or the CLA environment will list all of the function that ready to be used. So the total of the function is 514. Then now we will try to import. We'll try to import. So you can type. So we can import and then data and then dot chart. Okay, this function from data chart from this module will be imported. Now the import process is finished. Then now we want to count. How many functions for the current stage. So you can press tab button, and as we can see, the number of the function is larger compared to the previous step. So in the previous step, we only have around 514. So 514, and after we import the module, then we will have a larger number. The number is 639. Okay, and then if you want to see what is the functions, then we can type by or yes. You can later on check what is the difference before and after import the module of data dot chart. So of course there is differences between these two stages, because the previous one we use default function, and then for the second one or the second stage we already import the module. Okay, so if you want to implement this instruction, to check the type of the character, so we can type semicolon and then 2 per this. Then we can see the answer. Okay, can see the meaning of this one is the input is character, and then we will get the output as character. So let we try how to use this function. If we give a regular letter, then this regular letter will be capitalized. Actually, the meaning is same, A and A character, but different is the style. In the initial style is regular letter, and then for the after we implement this function to upper, then the letter will be capitalized into A, the capital of A. And if we try to another character, X for example, then so we will have X as a capital letter. Okay, next. So this is the implementation of a char function. In this case, toUpper is a function taking a character that char on the left side and returning another one because of the char on the right side. So the chr function is used to convert from a number to a char data type. The number is the code of the character. So this is an example of the function. Sorry. Okay. So this is the example how to use this function, the first function toUpper. For example, want to try, or maybe we already try this function. If we put a capital letter, then we will have the same result. And then the opposite of the toUpper is toLower. So into lower, if we put a capital letter, then the output will be a regular letter. Okay, and then to title also will convert the text become capital letters. Okay, and then another function is conversion from a number or the code, and then we will get the character as we used in the previous slide. Example 98. So you can just type chr 98, then we will get B, and then 97 is A, and then 99 is C, and then 100 is D. Okay, and then what is the characteristic of this CHR? Then you can type TCH. So the step is we receive the integer number, and then the integer actually is a code for the character. Then the compiler will convert this number into a character. So we have another function to find the minimum value between two integer numbers. So we can use min function. So we can use min function. So so we have to give, we have to use two values. So for example, min of 12 and 30. So what is the minimum value between these two values? So the result is, of course, 12. Sorry, 12 and 30. So the 12 is the minimum value because we compare with 30. Yeah. And then if we try another numbers, 100, for example, and then we put 1000, then the result, of course, the minimum value is between these two numbers is 100. Okay. Okay, I will continue to explain regarding the numbers. So the Haskell supports a great variety of number types depending on the width, precision, and support for decimal parts. So in the integer type is the bounded integer type, yeah? And then it supports values between at least plus minus. So this around plus minus 536 million, yeah? Plus minus from the positive to, or from the negative to positive number. So this is the interval. So the value is very large number of the Haskell, which correspond to 2 power 29, yeah, minus 1. So even though the GSC use a much wider range, so actually this range is very large. Usually values of the integer type have the native bit of the architecture which make them the fastest. So integer is unbound integer type, and then it can represent any value without a decimal part, without underflow or overflow. This property makes it useful for writing code without caring about bounds. So, but it comes at the price of speed. So there is a trade-off if we use with a large size. Of course, it can influence the speed performance. Yeah. So the Haskell-based library also bundles exact rational numbers using the ratio type. Rational values are created using n and then this percent, the percent sign, and then m. Yeah. So it's a unique function in the Haskell. So we can write, or we can represent, or we can process rational form. And then float and double are floating point types of single and double precision respectively. Let we try this part. So we can share the screen. So if we want to get the value of the power 2 power 2 is 4, the size is still small. It can increase for the power index. Increase to 5, then the number will be greater compared with the previous step. Then we try to increase to 100 or 10. So we can have a longer digit, yeah, of this number. Yeah. So it means we can have a greater number. Yeah. And try to add more numbers, yeah, for the power index. Yeah. Then we will have a longer digits. Yeah. Then finally, if we use a very big number, then we have very long digit of numbers. So this number is still integer number. And then how to use the ratio? Yeah, want to use ratio function. Then we have to import the module. So we have to import the module. Then if you want to type 1/2, and then the value is added to 1/3. So the result is 5/6. So all of these operations of the mathematical operation is performed as rational, yeah, rational numbers. Then we will also have in form of the fraction, yeah, form of the fraction. Okay, if we try to use another fraction or rational numbers, for 5, and then plus 6/5. Then we have 2/1 or 2. Yeah. Because if we multiply, we add, yeah, these two parts, 4/5 plus 6/5, the result is 10/5. 10/5 means 10 divided by 2. Yeah? Sorry, 10 divided by 5. Then we will have the result is 2. So here 2/1 equals to 2. Okay. Next, functions for number type. So we can convert, yeah, from decimal number, yeah, to a real number, or sorry, convert from a decimal number or a real number into a rational number, or a fraction. So yeah, we can try to implement to rational 2.25. Then we will have 9/4, right? 9/4. And then also 2 rational 2.5. So we will have a 5/2. As we know that 5 divided by 2 is 2.5. So this is a conversion from a decimal type to rational, rational type or decimal type. Then if we want to know what is actually this function to rational, then we can use T to okay, so from here we can get if we input a rational number A, then we will have rational no, sorry, if we put a real number, then we want to convert the form into rational numbers, then we can use this function. Okay. Okay, next, later on, we will try to the syntax for string in Haskell is similar to C. And then we have to wrap the letters using double quotes. The type name can be shown in the GSCI environment. So here we can use character. So a string, sorry, string. So what is the difference between string and character? In character, we use only a single letter, but in string, we use a combination of letter. So the string consists more than one letter. So we type hello world. Then we can we can get this description. Hello world is a string. And then if we type character H, then we can get the description. H is a character. So what is the difference? For the string, we use double quotes, but for the character, we use a single quote. Okay. And then if we mistake, if we mistake to use different quotes, then the CLA environment will refuse to process. For example, if we want to take the type of a string, but we use a single quote there to limit the size of the string. Then we will have this error. So we have to change the quote becomes double quotes. Okay, so we will have correct type for this variable or for this string. Okay. Now we will learn getting the list. So list literals. list whose values are as ex, explicitly set into the program code. So the lists are written with commas, then separating each of them of the elements while wrapping everything between square brackets. There is also special string syntax for a list of characters. Let's look at the types of some of these literals and function refers, which give a list of reverse order, and plus plus which concatenate to this. So here maybe we can demonstrate the first line. T then we will have a description for this list. List consists of 1 to 3, and then the type is numbers. Okay, and then so we can use function of reverse. So reverse will receive a list, will process a list, and then will return or will provide the result as list as well. So, we define list, or we can just reverse 1, 2, 3. Then the output is 3 to 1. So the reverse function will reverse the position. So the order will be reversed. Initially, element is in the initial point. Then the element will be shifted or will be moved to the final point. So change the position of the elements. If we add more element, 5, then we can see the order there will be reverse. And then this reverse also can be used for string then we will get this reverse text. Okay, and then there is also a function for concatenate, or joining two lists. Use double plus, and then we can add more elements. Then we'll have a new list. Actually, this list is composed by two lists. The first list is from 1 to 3, and then the second list is from 4 to 7. And then after we join these two lists, and then we will have larger list that the number or the element is from 1 to 7. Okay. Okay. Next, for the homogeneity of Haskell list. List in Haskell's homogeneous, and then each list can handle elements of only a single type. Because of that, we are forbidden to create a list containing integers and characters, and also to concatenate two lists with different kinds of elements. So list in Haskell should be composed from the same type, especially for the element. So the function that get information about the shape and the contents of the list are null, and then to check whether list is empty, we can use several function, such as head. For head, we will get the first element, and then tail to get the list without the first element. That means the remain elements after we take the first element or the head part, also known as the rest of the list. So the structure of the list of the first element becomes a head, and then the rest element becomes the tail. So let me try. Okay. For example, we want to create a new list, 3, and then we put another type A and E. Then there is error message, so we cannot proceed with this instruction. Or if we consist character, then we will have a concatenation of this character. And then to get the head of this character, you can see we will get, or we will extract the first character or the head part. Then for the tail part, so we will have only 2 and 3 because the element of 1 is already assigned as the head part. Then graphical representation of list. The figure shows graphical representation of the operators and the function on this. And then the colon operator is used to bind together an element with the rest of the list. And we can split those elements parts again using add and zero. Can also see how a list is a series of cons operation that always end with the empty list of the constructor. So this is the structure, the main structure of the list. Yeah. So the element is a head, and then the rest of the elements become tail. In Haskell also provides local expression and operators. True and false are the only two elements of the Boolean type in Haskell, and then several standard functions for combining these two values, and or, are provided also in the prelude. Prelude is the initial loading of the environment JSCI. So if we run this JSCI and then this default library is called as prelude. And then along with these functions, another important construction related to Booleans is if then else, and then an expression with the form if B then T else F evaluates to T if the value of B is true and it evaluates to F otherwise. This structure look similar to the one found in imperative languages. So I think there's not much different with the other programming language for the construction of the if then and then else. So if the criteria is not suitable in the if part, then the system should find another possible output. And then the comparison function between numbers are equality, inequality, and then greater than or equal to, and then greater than, and then less than or equal to, and less than. So we can use these operators to control the flow in the if then else. Next, list contain other lists as elements. So the inner list inside the outer list need to be of the same length. So they are not equivalent to arrays of multiple dimensions. One important thing to remember is that an empty list can be a member of larger list of lists. So single square bracket and double square brackets are not equivalent. The first is completely empty list of the list, and then whereas the second is a list that contain only one element. It's an empty list. So empty list actually is so the empty list is considered as a member of the list. Now we try to implement this instruction. Okay. 70. A, B, C. Then so D, and then so E. So we'll have this list, and then this one is the description. And then if we want to see what is the head of this, so the head is this one. So A, B, and C is considered as a single element of this outer boundary. And so for the tail, so this one only. Okay. Then if we get the head, see, then if you want to explore deeper, then we can input this word, ABC, then we will get the first element of this this. Then how about the empty one? Okay. Then if you want to create the empty one, so then we will have the head of this list is empty the empty the empty list. We try to get the tail, so empty. Okay, and then for the further exercise or further examples, you may browse these links. So you may explore these links, and then we will get the example, the code example of Haskell. Let me try. So the code is grouped regarding the topic. We're considering the topic. See here. Then we can try to implement one by one. So for the list, this one, we want to try in CLA command line interface. Then we can try here, and then we can clean. So here we put interspace, where we put uh, a dot, yeah, between the letters. Then maybe you can try so one. A, B, C, and then A, F, G, and then X. Expected. Oh, sorry. Today is from then this combination, yeah, combination of three elements. So you can try another functions. Yeah. Try to maybe it's better if you can try in this environment, yeah, CLI, then we can get directly, yeah, the result of its function. And then for the second website also is good, yeah, and then it's comprehensive. All of the basic materials of Haskell's covered, yeah, in this website. Yeah. So maybe you can try to copy paste, yeah, the equation, yeah, into your environment, and then you will get the result, or you get the feedback from the Haskell. Yeah. So this is a lot of codes, yeah. So you can just copy paste, yeah, the code from here, and then you can try by yourself in your PC. Okay, I think that's all for today. Is there any questions from the audience today on the Najla? Yeah.
Yes, sir.
Yeah. What happened with the other friends? Do they know that we will conduct the offline session or in-person session for today?
Yes, I think the others, I don't know whether they already read the group chat or not, sir, but I personally uh did not I only see the chat at past 8, sir, and I was like, oh no, I think I'm just gonna go with the Zoom because I don't think it's possible for me to go there at the time, sir.
Okay, yeah. So I will upload the recorded video, yeah, today. Then later on
Yes,
we
please, sir.
will access the materials and the video from the Google Classroom.
Okay,
Okay.
I'm very sorry,
Yeah.
sir.
Yeah, no problem. Okay. Thank you, Najla. So we will close we will end, the session for today. Thank you. Assalamualaikum warahmatullahi wabarakatuh. See you in the next session.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, sir.
Yeah, you're welcome.